Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on medical physics from October-November 2021 Paper 4 Variant 2. In this question, we will talk about ultrasound waves. We will discuss what is the function of quartz crystal, how we can use quartz crystal to produce and detect ultrasound waves. Then we will talk about acoustic impedance. At the end of this lesson, we will also discuss intensity reflection coefficient by solving past paper questions. For question number 11, part A, we need to describe the function of quartz crystal. In ultrasound, quartz crystal has two main functions. First function of quartz crystal is to generate ultrasound waves, mean high frequency sound waves, generate ultrasound waves. This is first function of quartz crystal in ultrasound, to generate ultrasound. And second main function of quartz crystal is to detect ultrasound waves coming back from the body, detect ultrasound waves. So these are two main functions of quartz crystal, ultrasound waves. Generate ultrasound waves. How it can generate ultrasound waves? In order to generate ultrasound waves from quartz crystal, we have to apply alternating voltage across crystal. So we can say apply alternating. So simply we can write down apply alternating voltage across crystal. So if we apply alternating voltage across crystal, crystal will be compressed and crystal will be stretched. So we can say crystal will be compressed and stretched. By compression and by stretching, vibrations will be produced. Means the crystal will simply vibrate. When crystal will vibrate, ultrasound waves will be produced. So ultrasound waves will produce. So this is how we can generate ultrasound waves using quartz crystal. You can look at this setup. So this is our quartz crystal and we have applied voltage across this one. So we have applied alternating voltage across this. So when we apply voltage across this one, this crystal will vibrate and ultrasound waves will be generated. The second thing, we need to understand how we can detect ultrasound waves. When ultrasound waves are incident on quartz crystal, means waves are coming back from the body, ultrasound waves incident on crystal. Waves incident on crystal. So we can write down when waves are incident on crystal, crystal will deform. So we will write down here crystal will deform. When crystal will deform, voltage will be induced. We can say induced voltage in the crystal, and that voltage can be used to detect ultrasound waves. So this is how we can generate ultrasounds using quartz crystal, and also we can detect ultrasound. So in ultrasound, same crystal is used to generate and to detect ultrasound waves. Now let me show you how we can write down the answer. Before I explain you how we can write down the answer, you can look at these two setups. The first one is telling you how to produce ultrasound waves. So in this case, ultrasound waves will be produced. So this is used to produce ultrasound waves. And the second one, this second figure, this is used to detect ultrasound waves. So when ultrasound waves are coming, they will deform this crystal. When this crystal will be deformed, EMF will be induced. So in this way, we can detect ultrasound waves. So this setup, this is for generation of ultrasound waves. We can call generation, and this is for detection of ultrasound waves. Now let me show you how you can write down a proper answer for this question. This is how you can write down your answer. In your answer, you can mention quartz crystal generates ultrasound waves if voltage is applied across crystal, which causes it to vibrate. So this has 2 points. Generate ultrasound, you will get 1 mark if you have written this. If you have written if voltage is applied across, you will get the second B mark. And the next one, it can be used to detect ultrasound waves because vibrations cause crystal to generate an EMF, or you can say voltage. So if you write down, you will get 3 marks. If you are a little bit more curious about this one, how EMF is induced, let's go to next slide. On this next slide, you can see here, this is our quartz crystal when it is unstretched or uncompressed. So positive, this is positively charged. Then the center of the negative, these oxygen ions, they are negatively charged. So the center of positive and negative charges is here. So it has no net charge. That when we compress this one, upper side become more positive. So you can see this side become more positive. So by compressing this one, we can induce voltage across this crystal by compression. So in this case, you can see it is unstressed, means no compression, no extension. But here, if we extend, vice versa is also true. This side become more negative and this side become more positive. So it means if we place voltmeter here, this voltmeter will give us value of induced voltage across crystal, and here is also true here. So this is how we can produce ultrasound waves, and this is also how we can detect ultrasound waves. For part B1, we need to define acoustic impedance, specific acoustic impedance. For specific acoustic impedance, we use symbol capital C, and this is equal to rho times C, means the product of density and speed. Rho here, this is density of medium. So we can simply write down density of medium. You have to explain these symbols as well. Density of medium. C is speed of ultrasound in medium. Speed of ultrasounds means speed of ultrasound waves in medium. So if you write down the formula and then you explain the symbols, you will get 2 marks. 1 mark you will get if you have written this formula. Then the second mark if you have explained these symbols. This is one way of writing answer, but you can also write down your answer in a little bit different way. You can also write down your answer in this form. If you write down product of density, so density you have to mention in your answer, and speed of ultrasound in medium, you will get 2 marks. So this is how you can define acoustic impedance. Very common question in past papers from ultrasound. For the second part, we need to describe qualitatively how the specific acoustic impedance of two materials affect the intensity reflection coefficient at a boundary between the materials. First of all, imagine that we have two different media. Let's say we have one media and we have another media. So this one is another media. Now in this case, acoustic impedance of medium 1, let's say is Z1, and acoustic impedance of second medium, let's say is Z2. If ultrasound waves are coming from the first medium and the intensity, imagine that is I0. When they will reach this boundary, means when these ultrasound waves, they will reach this boundary. At this boundary, some of ultrasound waves, they will be reflected back. So we can say intensity of reflected waves is IR, and some of ultrasound, they will be transmitted in the second medium, and let's say the intensity of transmitted ultrasound waves is IT. Imagine this intensity is equal to 100. So simply we can say 100 watts per square meters. Intensity watts per square meter, and this intensity, let's say this is 20. So this one has to be 80. Now if we write down intensity reflection coefficient, that one will be equal to IR divided by I0. So simply in this case, we will write down 80 divided by 100. It means this is equal to 0.8. So the intensity reflection coefficient for these two media is equal to 0.8. And intensity reflection coefficient we can also calculate by using acoustic impedance. So Z2 minus Z1 square, Z2 minus Z1 square over Z2 plus Z1 square. By using acoustic impedance, if we have acoustic impedance of these two media, we can use this formula, we can find out intensity reflection coefficient. But in this case, we need to understand if Z2 is equal to Z1. So this is case 1. So in this case, no reflection takes place. No reflection. No reflection. It simply means that if media is the same, ultrasound waves will not be reflected. Same media, it means no reflection. So we can also write down same medium. If the medium is the same, ultrasound waves will not be reflected. And medium is same if they have the same acoustic impedance. Now the second case we need to understand. So this is our first case. And the second case, if Z2 is much higher than Z1, then most reflection occurs. Most reflection occurs, we can say. Most reflection occurs. Means most of the ultrasound waves, they will be reflected back. So these are the 2 points we need to understand. Let's try to understand a little bit more in detail. If Z1 and Z2, they are totally different. Not only Z2 has to be greater than Z1. It is also true if Z1 is greater than Z2. So we can write down if Z2 and Z1 are very different. If they are very different, most of the ultrasound waves will be reflected. Very different, reflected. If almost same, means Z1 and Z2, they are almost same, then we can say little reflection. So we can say little reflection, or you can say most of the ultrasound waves will be transmitted in the second medium. Now let's try to understand what is the use of gel in ultrasound. Means why doctors they use gel in ultrasound on patient's body. The use of the gel is simply to reduce reflection of ultrasound waves. So simply we can say the purpose of gel is to reduce reflection. In order to reduce reflection of ultrasound, Z for the gel has to be equal to or almost same Z of skin. So if two media they have the same acoustic impedance, in that case reflection will be minimized. So that's the reason gel is used on patient body in ultrasound to reduce reflection of ultrasound. Now let me explain to you how you can write down a proper answer. In order to write down answer for this question, you can mention these 2 points. The first point you can say if the difference between the specific acoustic impedance is 0, then reflection coefficient is equal to 0. We can also write down this one in formula form, means IR over I naught. This is equal to Z2 minus Z1 square divided by Z2 minus Z1 square. This is plus. So IR, we can write down case 1. IR is equal to 0 if Z2 is equal to Z1. For the second case, we can write down IR is about equal to I naught if Z1 or Z2 is much greater than Z1, or you can say if Z1 is much greater than Z2. So these are 2 cases. If very different as in the second case, then reflection coefficient is 1, means IR is equal to I naught. So if IR is equal to I naught, we will get 1. So it means 100% reflection. So 100% reflection in second case. So simply you have to write down these 2 points, and this question is also very common in past papers. Try to understand these points about ultrasound. If you have understanding of these concepts about ultrasound, it means you have clear understanding of this topic.